The optimism is really something that's very reassuring. But
Yeah,
at the same time, while reading about a few, how should I put it, voices of dissent, perhaps, um, there has been a lot of, say, dissatisfaction with some of the, let's say, popular strands of science, because I understand that a lot of scientists, while engaging in scientific communication, in an attempt to, let's say, uh, establish resonance with the public, oversimplify or inflate the importance of, say certain concepts. For instance, I distinctly remember string theory being something very fascinating, and it was only later that I got to know about a lot of the incertitudes that it rests on. For instance, when Lee Smolin said that, completely dismissed string theory as saying that it makes no testable predictions, it has no coherent mathematical formulation, and that there has
yeah,
been an increase in, let's say, the number of dimensions, with, say, somebody saying there may be 5 dimensions and 11 dimensions, and then adding on more
yeah,
dimensions. And at the same time, I still
yes.
find string theory being very popular in, say, the popular understanding of the science. What do you think about? Do you share this, say, pessimism
Sorry, your sound has
vis-a-vis
broken
string
up
theory?
again. Yeah.
Uh, am I audible now, sir?
Sorry, say that again. String theory, was it?
Right.
Yeah. Oh,
Um,
I think it's fascinating. I mean, it's who knows whether it's true or not, but but it's string theory is certainly very compelling because it is an example of self-consistent mathematics, seemingly accounting for a wide range of phenomena, although it hasn't been tested really. It might be true. We don't know. Yeah, or some version of it might be true. Um, but it, I think in my heart I would like it to be true. But one's heart is not a good litmus test for for scientific validity. Um, so let me just simply say I would like to think it will turn out to be true. Yeah, and uh, I think scientists, maybe taking up your point in a slightly different way, scientists have a duty to share their insights with the general public. After all, a lot of their work is funded anyway through taxation. And so um, the general public is paying for a lot of the research that is done, even not necessarily directly, but even when they buy something in a pharmacist, then they are contributing to the profits of a pharmaceutical society, company. Um, so they are paying for the research that led to that particular pharmaceutical. Um, but it's broader than that. I think um, nation states also support the arts with as they are right to do, because it's a part of the cultural milieu of the society. That there is art, music, plastic arts, literature available to the population. That makes it all part of the pleasure of being alive, basically. Um, it's a shame that it goes on armaments too, but that's another story. Um, but I think also the other obligation for science is not just that people have paid you to do it, but it has deepened understanding. It drives back, in my view, my perhaps over-hopeful view, it drives out religion. I'll come back to that in a moment. And replaces it by truth, valid, publicly shareable, uncontestable, international, cooperative understanding. So it's good for the world and for individuals to be closer to the truth. Now, let me just say about driving out religion. The trouble is, religion is much easier than science. Religion can get away with saying, well, God did it. And the listener says, oh yeah, thanks very much. I always thought that was true. And they go off so happily into the sunset. Whereas science, if you say, well, I'm afraid this is going to be rather boring because I've got to take you through a chain of argument. I've got to start with something you appreciate, take you through some biology, maybe some chemistry, maybe further still into some physics, and who knows, into mathematics. So the listener has got to invest a lot of attention into comprehending science. Whereas in religion, it's obvious, and you get instant satisfaction. Because when you don't have any work to do, you just blindingly accept what you're told. So what we rational people are up against is impatience, because you need to be patient to pursue a scientific explanation, and so. It's very important, but we have to, if we go out into the world to trying to explain science, then we have to ask for patience, or we have to find ways that there's a shortcut around impatience. But I think that's what we're up against. Instant gratification from religion. Hard work, but rewarding hard work through science.
Very true, very truly highlighted about, say, the challenge of instant gratification that scientific communicators are up against, and how we should, say, not engage in oversimplification to, let's say, bypass this instant gratification. Another theory which comes to my mind when I think about how scientific communicators sometimes, not all of them obviously, but sometimes, let's say, offer very fanciful models, is the multiverse theory. Now, when I read your book, Conjuring the Universe, the one thing that struck out to me is that it doesn't multiply entities beyond necessity. It's a very simple exposition of how the universe could have occurred without, say, bringing in other parallel universes, or let's say bringing in strings or other fundamental entities. A very simple exposition. But then if you go on to YouTube and you find scientific communicators, you find very, very fanciful explanations. So sort of a follow-up to the previous question, how do you view, say, attempts to come up with theories such as the multiverse theory? Is it really a good way to approach science and scientific explanation?
What was the question?
Do you think that theories such as the multiverse theory, are an appropriate way to, let's say, engage in scientific explanations, given the fact that theories such as the one that, or explanations such as the one that you have offered, do not bring in gratuitous entities such as a parallel universe into the picture?
I'm still not quite sure what you're asking, but Are you saying that I'm taking a very Western view, a Western cultural view, and that
No,
I
no,
should?
no,
No,
no, no. No, no.
no.
I was asking in your explanation,
Yeah.
at least, okay, let me put it this way. I think Sir Roger Penrose criticized the multiverse theory by saying that why are you bringing in other universes into the picture, right? So, I mean, why do you need to bring in other universes? And let's say, what's the
Oh, I
difference
see.
between,
Yeah. Okay. You mean the multiverse
yeah, right. But then
and
your
many,
theory doesn't
many
do
more.
that at all. It's a very
Yeah.
simple explanation of, say, how the universe may have come across. And I think its elegance struck out to me. So, I mean, as a scientist,
Yeah.
how do you view such, let's say, fanciful explanations of bringing in multiple entities which you
Yeah.
can't really account for to explain the
Yeah.
universe?
Yeah. Well, um, let's put it this way. If the mathematics um, of the emergence of the universe, our universe, um, uh, indicates it, then we have to take it seriously. And so I have proposing that there are many universes is obviously um, almost a religion. By saying that, there is an answer out there, but I can't demonstrate its truth. I will accept it and so on. But if it turns out that there are many universes predicted, then we must cautiously look for manifestations of it. Now, it could be that the following is a little bit of indication there are more than one matter and antimatter in this universe. Antimatter. If what I said some time back about everything being really nothing, why is there that imbalance? Now, if you've got many universes, then some of the universes will have more antimatter than matter. Some of them will have more matter than antimatter. And so if you expand your conception of a universe to embrace all conceivable universes, this one and all other ones, then it all averages out to zero again. So you could say, because there must be nothing here, because nothing can come from nothing. Then if you find that there is something here, then there must be other universes which enables it all to cancel out. So there's a tiny sort of rather metaphysical argument, I suppose. But so the idea of many universes can be very useful. I think I know where they are, actually. But I don't want to go down this rabbit hole at the moment. Here's another wild speculation for you to reflect on. Suppose the universe could be regarded as a collection of points. In this universe, we know that this point is near that point, and that point is a long way from another point. In other words, this universe has a metric on it, which enables us to say what is nearby and what is distant. Now, take the same set of points and impose on it another metric, so that what these points A and B are now cosmic distances apart. And the one that I said was a long way away is now, according to this metric, is very close. So you can see you can build different universes from just by having a different interpretation of what point is next to what. That is, the different universes could have just different metrics. So they could all be assembled from the same points, but appear to us, this one that we actually inhabit. But you see, in other words, this universe would be pervaded by all the other universes, because it's all made up of the same points. It's just that our perception refers to the metric that we call this universe. So that's as wild a speculation as I'm prepared to do. But once again, I hope you realise that although I'm speculating, I'm not running off the tracks, the scientific tracks. The words I'm using, I hope I've tried to keep them as words of the scientific lexicon.
Absolutely, and I hadn't thought of that before. I mean, the fact that this argument about something coming from nothing and that something just being a more complicated form of nothing is something that can also be extended to the level of a supposed multiverse, in case we are willing to apply that. So, I mean, I genuinely hadn't thought of that.
It's a long way from physical chemistry, of course. But if I could just, I think we're coming to the end shortly. At least I have to go soon. If I can say that I sometimes wonder whether I should have been brought up as a physicist or whatever. On reflection, I'm glad that I went through the chemistry road and became a physical chemist, or chemist, per se, because it's widely said, and in fact is widely true, that chemistry is the central science. In order to do chemistry, you need to appeal to physics for the explanations, quantum theory, thermodynamics, and so on. By being a chemist, you need, at least my sort of chemist, you need to be able to understand physics to some extent. And you're driven, because chemistry is all about the manipulation of matter. You're driven also to understand what matter is. So you're driven deep into fundamental physics as well. But then on the other side of the chemistry's coin is biology, and the fact that increasingly biology is chemistry, and through molecular biology and so on. What someone said, a biochemist really once said, that nothing can be understood except in terms of evolution. That is true in terms of phenotypes and phenomenological biology, but nothing can be explained in biology except in terms of molecular biology, which is an application of chemistry. So by being a chemist, not only are you reaching down into the foundations into physics for your own understanding, but you're reaching out for application into biology and inorganic biology, that is material science, for the applications of your craft. So I'm pleased to have made a career that centered me in the middle of science.